Next problem in two-way classification with shifting the origin. 4 varieties A, B, C, D of a fertilizer are tested in a RBD with 4 replications. The plot yield in pounds are as follows. Carry out an analysis of variance. What inference can you draw from the data given? So first reframe the table. So fertilizers, so R is equal to 5 A, B, C, D, E, and yields number of blocks. There are 5 blocks. So for A, write down A data in the first row, right, and B data in the second rows, and C third, and D fourth row, and E fifth row, right? Here all CIs are equal to 5. C1 equal to C2 equal to C3 equal to C4 equal to C5 equal to 5. All are equal. So shifting the origin to 90. So subtract 90 from each number from the previous data. So you will get new data. So 112 minus 90, 90 minus 90, 134 minus 90, first column, 92 minus 90, 80 minus 90, etc. etc. Right? We are going to use this new data for our analysis of variance ANOVA. So here total number of items, that is equal to n 25. So column number 5, row number 5, and we are defining null hypothesis. There is no significant difference between yield column. Then there is no significant difference between the rows, that is fertilizers. H1 just alternative hypothesis. So alternative hypothesis is just opposite to null hypothesis. There is a significant difference between column, and the second one, there is a significant difference between fertilizers, that is row. Now calculation for ANOVA table 1. So write first table and the yields, then the data, revised data. After reframing the data, we will get, after shifting the origin, we will get, right? First row total 1, second row total minus 94, third row 148, fourth row minus 29, and last row minus 46. Similarly, column total. First column total 58, 12, and minus 10. So vertically you are adding the numbers. Fourth column minus 11, and fifth column minus 69. Then grand total G is equal to minus 20. Then you have to find Ri square by Ci. First R1 square by C1, that is 0.2. Then R2 square by C2, 1767.2. Then R3 square by C3, that is 5, that is 4380.80. Then R4 square by C5, that is not 4, that is 5, right? Minus 29 square by 5, 210.25. And last row minus 46 square by 5, that is equal to 423.2. Similarly for column. So first add up the summation, that is Ri square by Ci. So add up all the numbers in that particular column. You will get 6369.60. Then Cj square by Rj. So first column number is 52, right? 58, sorry. 58 square by 5, 672.8. Then 12 square by 5, 28.8. Minus 10 square by 5, 20. Minus 11 square by 5, 24.2. Minus 69 square by 5, 952.2, right? Then summation Cj square by Rj, that is equal to 1698. Next you have to find the sum of the squares. So first row square, sum of the squares, 22 square minus 8 square plus 0 square, etc., etc., like that. You will get 645. Second sum of square, row 3260, and third sum of square, third row 6166, and fourth sum of square, fourth row 309, and last row 616. Similarly for column sum of square, First column sum of square 2521, second 3126, third 886, and fourth 1851, and fifth 2609. Then you have to find the sum of square total, double summation xij square, that is equal to 10996. Next you have to find the correction factor. So g square by n minus 20 square by 25, that is equal to 16. Next total sum of square. So using the formula you will get 10980, right? Then row sum of square RSS, using the formula from the table you will get the required numbers 6369.60 minus 16, that is equal to 6353.6. Then column sum of square CSS, summation Cj square by Rj minus Cf, correction factor, right? So that is equal to 1698 minus 16, 1682. Then error sum of square or residue sum of square TSS minus CSS plus RSS, which is equal to 10980 minus 8035.6, 2944.4. Next ANOVA tables, source of variation, column, row, and error. Sum of squares CSS 1682, RSS 6353.6, and ESS 2944.4. Next degrees of freedom, first V1 C minus 1, that is equal to 5 minus 1, 4. V2 R minus 1, that is also 5 minus 1, that is equal to 4. Then V3 R minus 1 into C minus 1, 4 into 4, 60. Then mean sum of square column, which is equal to 420.5, and row sum of square, mean row sum of square, right, that is equal to 1588.4. Then mean error sum of square, that is equal to 184.03. Next F ratio. So first column sum of square, right, FC MCSS by MESS, which is equal to 2.29. Then FR with respect to row, that is equal to 8.63. Then we have to do the conclusion, right? For yields, degrees of freedom V1 V3 4, 16, right? A tabulated value at 5% level, degrees of freedom 4, 16, calculated value of FT, which is equal to 3.01. Comparing FT and FC. So FC is calculated value of column treatment 2.29, which is less than tabulated value 3.01. Therefore H0 is accepted. Next we are going to second treatment or fertilizers. So degrees of freedom V2 V3 4, 16. So at 5% level same 3.01, right? Now FR is greater than FT, right? The value of FR is greater than FT. So H0 is rejected in this case, right? Thanks.